Explore the seafloor without getting wet. This pressurized room is a part of the Archimedes diving bell ship. Used to salvage underwater valuables, a crew of 4 can comfortably spend hours below the millions of swirling gallons of water overhead. With roots to ancient Greece, Aristotle himself tells a story of the phenomenon that makes this possible. Even more surprising, Sir Edmund Halley, known primarily for Halley's Comet, played a key role in the final product. So how is it possible to create a permanent underwater bubble? Known as a diving bell, this device traps air within. While bubbles are known to be unstable and near impossible to handle, the diving bell is shaped in a way that compresses the air into itself, making the bubble more stable the deeper you drift to the sea floor. The concept of the diving bell has ancient roots, tracing back to ancient Greece. The first recorded mention comes from the philosopher Aristotle, who lived in the 4th century BCE. Aristotle described a device used by sponge divers that allowed them to remain submerged for longer periods. Aristotle's accounts mention an inverted cauldron or large kettle, which was lowered into the water with an open bottom. This simple device trapped air inside as it descended, creating a pocket of breathable air for the diver. While rudimentary, this early diving bell showcased a fundamental understanding of air pressure and its ability to displace water. But these divers wouldn't be able to remain at depths for long. In 1690, Halley designed an improved diving bell that addressed the challenge of limited air supply. His design included a large wooden bell, open at the bottom, with a weighted edge to keep it upright underwater. The innovation lay in how Halley managed to replenish the air inside the bell. Halley's diving bell was equipped with barrels of air, which were sent down from the surface. These barrels were weighted to sink and had valves to release air into the bell. This method allowed divers to receive a continuous supply of fresh air, significantly extending the time they could spend underwater. Halley's design was a major breakthrough, providing a practical solution to one of the key limitations of earlier diving bells. His system maintained air pressure inside the bell, allowing divers to work at greater depths and for longer periods. Halley's contributions didn't stop there. He also developed techniques for managing the air pressure and temperature within the bell, making the underwater environment more comfortable and safe for divers. His work laid the foundation for the sophisticated diving technologies we have today. The diving bell ship is a specialized maritime vessel designed for underwater exploration, salvage operations, and construction work at significant depths. The diving bell is connected to the ship by a series of cables and hoses, which supply air, maintain communication, and ensure the chamber's internal pressure is kept stable. These ships are often equipped with advanced winching systems to precisely control the descent and ascent of the diving bell, as well as sophisticated navigation and positioning systems to keep the ship steady over a designated spot. Historically, diving bell ships were instrumental in underwater archaeology, enabling the exploration of shipwrecks and sunken cities. Over time, the technology has evolved, with modern diving bell ships often incorporating robotic arms, remote-operated vehicles, ROVs, and even saturation diving systems, allowing divers to remain at depth for extended periods. These advancements have expanded the scope and safety of underwater missions, making diving bell ships a critical asset in deep-sea exploration and underwater engineering projects. If you learned something interesting today, please leave a like and learn another tomorrow.